once again, welcome to the IMTS Creators Lounge. We're watching all the people walk around. My name is Scott McKenzie, host of Industrial Talk, and I am absolutely, like you, all out there, super duper happy of being at IMTS. Thank you very much. We have an incredible conversation. Sid is in the house. Sid is in the hot seat. He's with Hitachi Vantara. How are you doing, Sid? Got you off guard, didn't I?
I'm doing great, but would I be able to mimic even a fraction of your energy?
Give it a shot. Industrial Talks.
Let me try.
That's right. So you just arrived today, just today.
Today is my first day.
Are you going to be here for a couple of days, or are you just
I'm going back tomorrow.
Because you're
that's
that
the last,
important.
That's the last day of IMTS, right?
I think it goes on to Saturday.
Oh, really?
Yeah.
So I'm missing out on Saturday for sure.
You pretty much, because you're going to go to a meeting, you're going to do this, you're going to miss out on all of this stuff out here.
This is good. I mean, but did you see a trend in this IMTS which was slightly different? More robotics, more laser.
Oh, yeah.
More water technology, more abrasives.
Additives. I mean, that additive manufacturer is like going through the roof. Yeah, I interviewed a guy that does... what is it for tracing? It was for tracing. Anyway, it was, they're able to add to the additive manufacturing the ability to be able to trace it. Nanotechnology. It just sounds cool, huh?
Yeah,
it's today. It's not yesterday. Yeah. Anyway, it's all cool. Now, for the listeners out there and the people who are watching, give us a little background, a little 411 on who Sid is.
Sid currently is managing
sporting a
IoT.
Mad beard. I like your beard, man.
Sid is currently managing IoT and OT in Hitachi Vantara. But I've done many things. Like before this, I was heading industry solutions for a very large Japanese conglomerate. Before that, I was leading an industry, process manufacturing globally. But I started my career as a steel plant manufacturing consultant and an SAP consultant. So that's the 25-year journey.
How long have you been with Hitachi Vantara?
Hitachi, I'm close to my 2-year landmark in Hitachi.
Now
we call it Hitachi family, by the way, because because it's a huge conglomerate. We call it a family.
It is. It's massive. But even in that 2-year time, Sid, you've seen a lot of changes.
Oh, absolutely.
Like massive changes. It's like,
many things. For example, we went ahead and shared with the world our intent, and we put our money where our mouth was. Look at all the industrial giants and look at Hitachi. The amount of investments Hitachi has single-handedly done on digital technologies, digital engineering, software engineering, and using software and digital inside the context of industrials is more than many of them put together. And I'm comparing Hitachi with Siemens, I'm comparing Hitachi with Rockwell, Fanuc, I'm comparing it with ABB, I'm comparing it with Emerson. So if you compare these organizations, Hitachi in 1 year post-COVID, I'm talking about 21, it has done more investment in digital in the context of industrials than any of them.
So it begs the question, why?
See, because two reasons. One, I think there is a recognition within Hitachi and in the larger industry that the machine which we knew is going to become increasingly software enabled. And the bill of material of that machine or the bill of material of that industrial contraption is going to increasingly have more software layers. So for an example, one bogie of a rolling stock passenger train today has 2.7 million lines of code. 10 years ago, it had none.
That's a heck of a stat. Yeah, that's an eye-opener.
So just imagine.
So yeah, you see the trend that I believe that. Now, we're here at a manufacturing show, off the charts. What are the challenges? What are the challenges these manufacturers are dealing with?
So, see, if you ask this question to anyone, obviously, right? You are in this. You are one of the experts in this. Everyone will color.
I
the
just
answer.
chirpy chirp. You're the expert. I just listen to you.
You're the expert in what you're doing. I'm saying everyone will color the answer with their own nuance. But in my humble understanding, there are many changes happening in the end product. Let us take the example of automotive. Automotives are having a cash cow, which is internal combustion engine. That is the cash cow. But they know that they might have a Xerox moment or they might have a Canon camera moment if they do not dehyphenate themselves from internal combustion and predicate their entire strategy to BH, battery powered, and electric vehicles. But do they have enough capital to start creating fresh new factories? So they need to repurpose the current factories in a very intelligent way to increase the electric vehicle manufacturing while protecting the volumes of internal combustion on the same lines, on the same capacity, with the same workforce, and most probably with the same set of suppliers. Big challenge. Look at the transformer manufacturing industry. One of our divisions in Hitachi is Hitachi Energy. They are arguably the world's largest three-phase and single-phase transformer manufacturers. I was talking to the head of sales of Hitachi Energy in North America, and he said that the lead time from taking an order to supplying a three-phase transformer used to be 16 to 17 weeks pre-COVID. And today, hold your breath, it is 78 weeks. So companies are pre-ordering what they need 6 years and 7 years down the line. So their order intake is massively more than what it was pre-COVID, but their capacity is same. So they need to find newer mechanism of increasing productivity, decrease this lead time, scavenge for the raw material, which is basically sheet metal and all the amazing tooling you are seeing in IMTS. Tap into the workforce, which is the scarcest commodity on the planet today, and then keep your customers happy and keep the lights on. Because if a transformer is failing, then the entire city or a metropolitan is going down.
I'm ready to hit the ejector seat there. I'm ready. I don't know where to go. I don't know what's the answer. I mean, outside of the obvious, that greater asset utilization, repurposing existing assets, and all of that. Is that really the way of doing it?
No, I think the answer is, I would like to steal words out of my CEO's mouth, Gajen Kandia. He says that the answer is interpreting the nuances hidden in the data better and capturing more and more data to understand how and where you're losing productivity.
See, we can definitely venture into that area where for me personally, I hear you. And if I was a business and I would say, yeah, that's great, we need to capture data, I wouldn't even know where to go. I wouldn't even know where to start. Is that good data? That good data? What if I married to what answer is being provided in that combination of data? That's where you guys shine.
No, but that's a profound observation. So you just, I think, while you were making that comment, you flirted with one of the most important problems in data. So we were just yesterday talking to one of the largest automotive manufacturing companies on the planet. And they were saying that, hey, if I take an IoT solution to a new plant, I want to do a bulk asset upload. Rather than creating one asset at a time or rather than building an RPA, they want to just press a button and take out all the assets from the plant. Now, the problem is, this is impossible because the asset models have to be mapped to the target and destination.
Do that. The
target is maintenance oriented. The destination is prognostics and physics oriented. So there is a new concept which is creeping into manufacturing, and it's called global namespaces. So what manufacturers are being told is that, hey, you have multiple data sets with different taxonomies and ontologies. So rather than harmonizing everything, create a global namespace. So rather than harmonizing the ontology and the taxonomy of the data, start harmonizing the namespace, which means if there is an asset called Sid and if there is an asset called Kevin, so Kevin and Sid can be a global namespace, and all the attributes, the maintenance attributes, the prognostic attributes, the physics, the modeling, they can all be the sub namespaces inside the global. It's very similar to object-oriented programming.
Wow, I haven't heard that in a long time. I remember that. What's interesting, I see the need to sort of incrementally approach. I think you need to get some victories in your belt. I just think that, this is what and prove that out. Now, for me personally, and having multiple conversations, I hear the word edge. I hear it all the time. I hear it even in my house. Can you help us understand that?
Okay, if I'm able to do that, and if there was a Nobel Prize in manufacturing, I might be nominated for that. See, edge, and again, so I can see that all the questions are very relevant. See, edge is the most misunderstood or poly-understood phenomena I call it misunderstood or poly-understood. So there is no single definition of edge, and we can take an example of any shop floor. So on a shop floor, a machine is definitely an edge, but that machine has a bill of material, and some of the bill of materials are sensorized. So that is an edge. But the machine is harnessed on a platform, which itself is sensorized and connected to a field bus. That is an edge. The entire data is going to a Modbus. That is an edge. Then there is a network control router and network address control switchgear. That is an edge. Now, if you might have a 5G mech, that is an edge. And eventually, if you're dealing with millimeter wavelength and ultra high frequency of 5G nature, there is a POP device, that is an edge. Your security gateway is an edge. Your multi-protocol gateways on the plant are edge. Everything is edge. So again, I think we need to define what I have started calling it, and I won't claim that it is my term, but very few people call it. I call it contextual edge. See, we need to look at the outcome and the use case and then see what is the contextual edge for that particular use case and that particular outcome.
See, and it's interesting because you brought up a good point. You named a number of items that are edge, and they are, they're right there. But for me, in my simple mind, it was I see a shop floor, I see this box over there, it's the edge, and then it sends it up to the cloud. That's sort of, and this edge device says, oh yeah, I'm receiving data, and that data I don't need, but this data I do need, so I'll send it.
So that's a great way of simplifying everything. But today, on a shop floor, there are multiple devices which are directly connected to either a private cloud or a public cloud. And if you look at the public cloud, AWS and the Azures, they are stepping into edge. They are bringing the power of cloud into edge. If you look at the Snowball family of AWS and the Monitron device of AWS, and if you look at Stack Edge of Azure, they all are bringing the power of hyperscalers into the edge, because edge is very important. And that is why Hitachi is building and going to launch a very new concept, which we are going to call Hitachi Industry Cloud. It will have a continuum of connectivity and use case orchestration from edge to cloud. And we are going to bring...
Go ahead, keep on going, because you're touching on something.
So we are going to bring in the crystallization of our years and years of experience in business processes and domains, templatized into libraries, data models, data architectures. And we are going to abstract the user from the complexity of where my data is getting orchestrated. So the user should not worry whether my data is getting involved with edge or a private cloud or a multi-cloud or a hyperscaler. So we are trying to build that concept, and that is something which we are working on.
That is an aha moment for me, because when you started rattling off different types of edge, fine. Of course, my mind goes to, well, those are all sources of possible data. And then for me, I'd want simple. I don't want to know about how the data sausage is made. I don't want it. I want that to be programmatically solved for me and then displayed in a way that makes me feel warm and fuzzy and makes me do my job better.
Absolutely. So the user should only be worried about outcomes and
That's it.
visualization and form factors. Can I access it on my mobile device, handheld, tablet, and PC, and in what form and what differences? And what will I lose between my mobile device and my PC? That's it. The user should not be worried about whether my data is going to reside in edge, whether I'm going to archive it somewhere. Oh, do I need a private cloud? Do I need to add extra capacity? Oh, I have a SaaS and a LAS and a PaaS and a hyperscaler. Man, we are there to worry about it. We will abstract this entire Byzantine spaghetti for you.
That's it.
Yeah.
It's spaghetti. I don't want to see that. And if I'm in manufacturing, I know that I have all these data. I don't want to see all the sausage there, or energy, or transportation. The same thing exists.
Same thing in different
across the board.
So different. So in every industry, there is something new which is happening. I took a small example of manufacturing. You go to utilities, the entire grid is unidirectional, generation to transmission to distribution. But now there is an element of bidirectionalism coming in. So there is no device which is completely geared towards a bidirectional grid. So the grid of the future, the renewable grid, the green grid, would be bidirectional. The smart grid, it will be bidirectional. Now, to make it bidirectional, you need devices and you need the sausages in the way which are bidirectional. So the sausage factory should again be abstracted from the user and prosumer.
That's brilliant. And you don't have to come into a company or an organization or a manufacturer and say, hey, you're going to have to implement all of this stuff. No, we're going to reveal the data that is necessary to make you a success, create that business that is resilient, whatever it might be. And we're just going to compress the time to data, to visualization, and then you can do your job, be more optimized, whatever it might be, whatever the term is. And that's across the board, and that's with everything. But that whole utility thing,
the utility,
that's way above my pay grade, because
utility is beyond all our pay grades, because it's a federal thing, it's a geopolitical thing. Look at what is happening in Ukraine and Russia. The entire war is creating an energy crisis in Europe. Now, see, if Europe keeps itself hyphenated with fossil fuels from Russia, then they are going to keep running into a very high electricity bill because Mr. Putin. But the point is, if Europe is able to dehyphenate itself in the right time and in the right ways and modernize its grid and look at green hydrogen, look at renewables, look at its own self-sustaining atomic and nuclear power, a Fukushima disaster should not be a reason to shut down all the nuclear plants in Germany.
Super thumbs up on that statement. Absolutely. Now we also, I want to roll in digital twin. Okay. Now, where does digital twin play in all of this?
Digital twin is, I will say it is a very close cousin of edge when it comes to complexity in understanding. So people understand it in different ways, but see, the way we in Hitachi interpret and understand digital twin is a model which replicates real life. And the relative distance of time, or the relative delay in time between the real life and the model, needn't be real time. It totally depends upon the use case. So a digital twin can be even a 30-minute delayed digital twin. If the use cases can tolerate 30 minutes of delay, or the digital twin can be a microsecond delay if the use case cannot tolerate that more than a microsecond of delay. So the use cases which govern digital twin are basically mission critical simulation.
Very good.
So if you're running a very high speed train and the wheelbase of the train needs to be digitally twinned at perhaps a microsecond, the signaling systems need to be digitally twinned at a second. And maybe the rolling stock, the carriage and the HVAC can be digitally twinned at a 15-20 minute delay. So digital twin is basically watching and observing real life from distance.
So the reality is, Sid, if I need to get a hold of you and I need to be able to say, hey, I don't want to see how the sausage is made, the data sausage. I'm going to go to the data sausages king, and that is Sid. How do they get a hold of you? I mean, if they want to get a hold of, they're listening to this and they're saying, I hear what Sid's saying. I want to be able to get a hold of him.
So Sid is a part of a very large community of some very brilliant people in Hitachi Vantara, and I would like everyone to be invited to our labs, our innovation labs, which are in Santa Clara and which are in Detroit and Pennsylvania
Excellent.
and Dallas, and reach out to me. I'm in mail me sid.sharma@hitachivantara.com.
There you go. All right. Thank you very much, Sid. Man, that was great. I love that. All right. Thank you very much for joining IMTS Creators Lounge. This is Sid, company's Hitachi Vantara, and definitely you need to tap into that data. You need to figure that out. Make that a priority. Thank you, Sid.
Thank you.